Hello and welcome to Teach Up, where we show you how to do well on the AP Calculus test and how to be fast. Today we want to find the equation of the tangent line to this curve, 25x squared plus 9y squared is equal to 43 through the point negative 2, 1. We may recognize the equation to describe an ellipse, but it's not something we actually have to really know in order to answer this question. So let's just go ahead and remember that the equation of the tangent line is given by the equation y minus y1 is equal to the slope times the quantity x minus x1, where m here is the slope of that line and x1, y1 would be a point on that line. Because we want the equation of the tangent line to this curve, then we're going to have to take the derivative. Now, this equation is described implicitly, so we're going to use the implicit differentiation process to find the derivative. So what we're going to do is take d dx of one side of the equation, that's 25x squared plus 9y squared. We're going to set that equal to d dx of the other side. Okay, so just to be consistent with my colors, so d dx of 43. Now the right side is pretty straightforward. The derivative of a constant is going to be 0. A constant doesn't change. And on the left-hand side, we're going to just take the derivative term by term. So the derivative with respect to x of 25x squared would be 50x. And we're going to have plus the derivative of 9y squared is going to be 18y. And let's remember, we also have to have dy dx because we're taking the derivative with respect to x. So then we have to isolate dy dx. So we start by writing 18y dy dx is equal to negative 50x. Divide each side by 18y. So dy dx is equal to negative 50x divided by 18y. Now there's a common factor here of 2. If we divide 50 by 2, we get 25. Divide 18 by 2, we get 9. So the answer is negative 25 over 9, negative 25x over 9y. So excuse me for that. All right, we wanted to find the slope of the tangent line at the point negative 2, 1. I'm going to just scroll up real quick just to make sure I have the right point. So at negative 2, positive 1, then since this is the derivative of the line that is tangent to that curve, then I have to substitute x equal negative 2 and y equal 1 into negative 25x over 9y. So that's going to give me then negative 25 times, negative 25, I'm trying to undo. Okay, now it's undone. Negative 25 times negative 2 divided by 9 times 1, that's going to be 50 over 9. So the slope of the tangent line at negative 2, 1 is going to be 50 over 9. So we're going to then use the point slope formula and say y minus y1, that's going to be 1, is equal to 50 over 9 times the quantity x minus negative 2, so that's going to be x plus 2. Now notice that all of the answers that I'm given here in my choices are written in standard form. So I'm going to have to change this into standard form. We're going to multiply each side of the equation by this denominator here of 9. So that way I can divide 9 by 9 and get a 1. So I'm going to get 9y minus 9 is equal to 50 times x plus 2. So 9y minus 9 is equal to 50x plus 100. Let's go ahead and add 9 to each side. So we have 9y is equal to 50x plus 109. And then subtract 9y from each side. That's going to give me 50x. Oops, excuse me. I just really dislike it when that happens. But okay, 50x minus 9y plus 109 is equal to 0. And then we're just going to go up and find that the only answer that says 50x minus 9y plus 109 is equal to 0, that's B. Let's be careful not to select A, because 6A here, let me just take out that strikeout, but A is negative 50x plus 9y plus 109. If this had been minus 109, it would have been the same as B, but it is not. So let's just be careful there when we're selecting our answers.